Hello friends, and welcome to the final video on functional interfaces. In this video, we will do a quick summary or a quick recap of what we have learned about functional interfaces and lambdas. So, as we saw, functional interface is an interface or a type of an interface which only has a single abstract method. So just to explain it further, an interface which has just one single abstract method is a functional interface. We have seen a lot of examples like runnable, callable, comparator, comparable. All these are predefined functional interfaces which are available in our Java package. But you can also write your own functional interface. You just define an interface with just one and only one abstract method. And if you want, which is also a good practice, is to mark or annotate that interface with @functional interface. Let's see the next point. These single abstract methods are also called as SAM or SAMs. So a functional interface can also be referred as a SAM interface. The full form of SAM is single abstract method. So you can see the highlighting where I have highlighted the first words of each first character of each words. So functional interfaces are also known as SAM interfaces, and the abstract method in a functional interface is also called as a SAM. There are different ways in which we can instantiate a functional interface. So as you already know, interfaces are a contract, and that is the same rule that applies to functional interfaces also. Functional interfaces are just a contract which defines what has to be done. The how part can be implemented by either the classical way, where we have a class that implements the interface and overrides the abstract methods, or the other way of implementing or giving definition to the abstract method is using anonymous in a class. These approaches we have already seen in the previous videos, so it's nothing new for you guys. The other and the most effective way of giving definition to a functional interface is using a lambda. So let's go on to the next point. Yes, this point says the main purpose of lambda is to give definition to a functional interface. So if you remember, a functional interface will only have a SAM or a single abstract method. To give definition to that SAM, we have a lambda. So the sole purpose of a lambda is to give definition to the SAM of the functional interface. So we saw that in the example of runnable, where the lambda's sole purpose was to give definition to the run method. We saw it in the add two numbers functional interface in the calculator interface, where the SAM in the calculator functional interface was called the add, if I'm not wrong, and the lambda that was used was just to give definition to the add method, right? So that's the point. That is the important key that you should take away from this video or from this video series about functional interfaces. The next point about functional interfaces is a functional interface can only have one and only one abstract method, but it can have any number of default or static methods. For the moment, just hold this point in your mind, especially on the second part about default and static methods. We will see what are default and static methods in an interface. But just remember, or just keep this point somewhere in your mind, so that we will come back to it and I'll explain it in great details. So for now, just imagine that a functional interface we'll have only a single abstract method that you have already seen. But about default and static methods, it can have any number of default and static methods. So just keep this point in your mind. We will come back to this in the second part. The next point says a lambda should always be linked to a functional interface. Yeah. So this point links back to what I have said. The sole purpose of a lambda is to give a definition to a functional interface, to give definition to the SAM or the functional interface. That means whenever we define a lambda, it has to be linked to a functional interface. Because what is a lambda? Using a lambda, we are giving definition to the SAM or the single abstract method of a functional interface. Going to the next. To call a lambda, we need a reference of the functional interface. This point we have seen in the runnable in the calculator method, where a lambda by itself cannot exist. It has to be linked, or it has to be referenced, or it has to be of a certain type, right? So when we implemented a lambda for the run method for the runnable functional interface, what did we do? We said runnable, we created a reference, and that reference we were pointing to the lambda. In the same way we did for the calculator, where we created a reference of the calculator, and that reference was pointing to the lambda. So a lambda has always to be linked to a functional interface, and it cannot live by itself. Thank you friends, hope you like this video. See you in the next series of videos on Java 8. Thank you.